In this problem, we're told a leaky 10 kg bucket is lifted from the ground to a height of 12 meters at a constant speed with a rope that weighs 0.8 kilograms per meter. Initially, the bucket contains 36 kilograms of water, but the water leaks at a constant rate and finishes draining just as the bucket reaches the 12-meter level. How much work is done? So we're trying to find work, and I'm going to draw a diagram of what's going on here. So we have this rope, and it's going to be lifting this bucket, right? And so here's going to be our bucket. So this is our bucket. And so we know this bucket is going to be 10 kg, the bucket itself, right? But then there's going to be water inside of it. At this point, there's 36 kg water, and we're lifting it up 12 meters. So here, right here is going to be a drawing of what's going on. And so we're given, we need to find the work. And so what you need to know is that you split the work up into different things. So we need to find the work of bringing it up, right? So the rope, we got to find the work of the bucket, and then we have to find the work it takes to move the water. So there's going to be 3 different integrals that we use to solve this. And so I'm going to start with the rope. And so we know the rope weighs 0.8 kgs per meter, or kilograms per meter. And so you should know that that is that's going to be a mass, right? So this is the mass per meter of rope, but we need to make sure we turn it into force, because we know work equals force times distance. And so we're going to make force a function though. And so if we go ahead and solve for force, right, 0.8 kgs per meter, we got to multiply it by acceleration. And so acceleration is 9.8. If you go ahead and multiply this, you're going to get 7.84. So force is actually going to be 7.84. So that's going to be our force, right? And then what you want to do is take this number, and you're going to take the integral, right? Then we're going to calculate the force, or the work. So the work is going to be the integral from the distance you change, right? So we start from 0, and then we move it up 12. So it's essentially taking the integral from 0 to 12. And then imagine the force as a function. So the force is going to be 7.84 times x, because x is just going to be the change or whatever. So we want to make sure it's as a function. So it's really going to be 7.84x. And then d, we just call delta x, right? So you're going to want to take this integral from 0 to 12. This is going to be the work of the rope. But there's 2 other things we have to take the work of. Now we're going to take the work of the water draining out of the bucket. So we're going to add this integral to the integral from, and so keep in mind we're moving this also up from 0 to 12. So this integral, so keep in mind this is rope. So we're going to be doing the water next. So water. And so this one, you're going to do the exact same concept. So we need to solve for the amount of water that changes based on how far we're moving it up. So we need to find the amount of water based on where we're at, right? So we know it starts with 36 kgs of water, and then the water leaks at a constant rate and just finishes as it reaches the 12 meter, right? 12 meters. So once it goes up 12 meters, it should equal 0. So if we do 36 minus 3x, that's going to find it, right? So if we plug in 12 into this, it'll be 0. So this is going to be our function that represents, right, because we're trying to find force. That's going to be our mass, but we need to multiply it by acceleration. And so that was the mass, what we just found. But essentially, right, because the water, its mass is that. And so if that's our function, right, so we have 36 minus 3x, that's going to represent almost this function, right, because this one takes into account acceleration. This one doesn't yet. So we also have to multiply this by 9.8. So 9.8 times 36 minus 3x, and then don't forget to find work, we have to have delta x after. So this is our water integral. Now let's find the last one. So the last one is going to be taking into account the bucket. And so we actually don't need an integral for this. You can just solve it this way. So we know the bucket. So we know work equals force times distance. And we know what the distance is. So the distance is going to be 12 meters. What's the force? Well, we know it stays at this constant 10 kg, right? So nothing really changing with this. So if we want to find force, we just have to take our weight, right? Mass. Force equals mass times acceleration. We just need to take our mass, which is 10 kg, and then multiply by acceleration, which is 9.8. And so if you go to this 10 times 9.8 times 12, if you go ahead and do that, you're going to get 1,176. And then keep in mind when you measure work, it's in joules. So the work for the bucket is going to be this amount of joules. And then I'm not going to go through and solve these integrals for you guys, because hopefully by now you should know how to solve integrals like this. But if you solve this one, you're going to get 564.48 joules. And then this one right here for the water is going to be 2,116.8 joules. So if we have the work for each individual component, all we have to do is add them up. And that's going to give us the total work. And so if you add these up, 564.48, 2,116.8, and 1,176. If you add them up, you're going to get about 3,857 joules. So this right here is going to be your answer. And so hopefully you found this video helpful.